So there are two different ways that we can go with Dr. Sebi. One strand would be supervised learning algorithms, and the other would be unsupervised learning algorithms. And so what I want to do is take the group of 6 and split you guys into 3 and 3, and have one group move to the left and the other group move to the right. And I guess the first thing that we should all be on the same page about is what is the difference between supervised learning and unsupervised learning. And so an easy way to explain that would be here with the IRIS data set. It was taken by Ronald Fisher, a biologist, where he sat down and in one sitting he measured the sepals and the petals of 150 different irises, and he categorized what type they are: setosa, versicolor, or verinica. And so if you go into, or you might have run across this data set previously, but when I was going through an introductory machine learning curriculum, this was the first exercise that I saw. Right? And so how would a supervised learning algorithm figure this out, and what would be its purpose? Well, the purpose would be to give the machine learning algorithm the sepal length, width, and petal length, and then have it tell me what kind of flower it is, right? Which of the three. Another application would be to have the different characteristics of a piece of fruit and tell me, what is it? Is it an apple or is it an orange? And so a supervised learning algorithm would have these labels, right? And so you would have a set of training data, right, where you could take all this data, feed it into your machine learning algorithm, and your algorithm would come up with a set of rules depending on the different characteristics, and it would tell you what type of flower it is. And so after the machine learning algorithm learns from the training data, you can go ahead and feed it a set of sepal length, petal width, and petal length, and it should tell you accurately what type of flower it is. Right? So that's supervised learning. And what is unsupervised learning? It's where you have the data but you do not have the labels. So unsupervised learning is more, it has that level of complexity, because the first thing you need to do is you need to group the data in a way that's meaningful, and then provide labels to that data so that you can deal with a large data set that apparently has no order, right? So create order out of disorder. And so so 3 of you guys, I want you to, maybe you could start here and split these different topics up, dive into it, and explore. The other 3 of you can find an unsupervised learning I guess topic list and then dive into that, right? But I guess a clearer way of describing unsupervised learning would be this pizza algorithm. And so this is something that we went over in the early into a couple tasks before this one here. And what is the problem? It's you have the data of who is purchasing pizzas, right? What's the locations of their houses, and you're asking yourself, where should I open up a pizza shop in order to service these locations, right? Or best service them most efficiently. And so the first thing you would want to do is group them, right, using graph clustering, and then you're going to place the locations closer and closer to the clusters. And as your algorithm learns, it will redefine what those clusters are and then move the locations closer and closer to the center until you get something that looks like this here, right? And so this is one application of graph clustering, but there are many applications, right? And so this might be an area of study that we move forward with. But to start out, why don't we go ahead and take a higher level view of the different strategies that are used in unsupervised learning, and then we can decide as a group or even as pairs, depending on how much support Dr. Sebi is going to give us on which area we're going to move forward with.